Hey everyone, C Language Explainer Key, Swagatham, welcome. Today we are unlocking something literally foundational and honestly super powerful in programming. We're talking about the while loop in C. You know, if you're learning how to code, mastering loops is kind of like getting a superpower. It lets you automate tasks so your software actually does all the heavy lifting for you, and I am absolutely thrilled to guide you through this today. But before we look at any actual code, let's just think about a fundamental problem for a second. Imagine you need a program to print a word 10,000 times. You wouldn't sit there and manually write 10,000 lines of code, right? I mean, no way, that would be exhausting. Software handles this kind of repetition completely seamlessly. But iti ella work outthandi. Like, how does this actually work? How do programs know exactly when to start and, more importantly, when to stop running a process? Well, that is exactly where our hero today comes into play. Okay, let's dive into this. Today we're going to cover what a while loop is, check out the syntax and flow, walk through some actual C code, look at real-time examples, weigh the pros and cons, and finally talk about the dreaded infinite loop warning. Section 1. What is a while loop? The basics of repetition. At its very core, programming is all about logic and efficiency, right? A while loop is just a fundamental control flow statement. It's designed to execute a block of code repeatedly, as long as the specific condition remains true. And this brings us to a really critical programming term that you absolutely must remember, the entry-controlled loop. I really want to emphasize that, entry-controlled loop, elegante, because the condition acts just like a strict bouncer at the door of a VIP club. The loop checks your ID, or, the condition in this case, before the loop body is allowed to execute even a single time. If the condition is false on day one, you just don't get it. Section 2. Syntax and execution flow. Let's see how it works step by step. So here's the basic syntax. It looks incredibly simple, but it is super powerful. You literally just write the keyword while, followed by a parentheses. And inside those parentheses sits your condition. This condition is that strict gatekeeper I was just talking about. If that condition evaluates to true, boom, the program moves inside those curly brackets and executes whatever statements you've got written in there. To see how this actually stays in motion, let's walk through the 3 steps of execution. Manduga, first off, the condition is checked. Tarvata, then, if it evaluates to true, the statements execute. But here's the magic. After the statements run, the program doesn't just move on to the next thing. Nope, it loops right back up to step 1. It checks the condition again and again and again. This engine of repetition only stops when step 1 finally evaluates to false. Section 3. C code explanation. Let's see the loop in action. Let's look at a standard C snippet and its output. We start by declaring our integer variable, so int I equals 1. To get that output of 1, 2, 3, 4, 5, our while loop is just quietly working in the background. It basically asks, hey, is I less than or equal to 5? Since 1 is obviously less than 5, it prints 1. Then inside the loop, we update I to 2. It checks again. This continues incredibly smoothly until I hit 6. At that exact moment, the condition becomes false, the loop terminates, and we are left with this perfect sequential output. Section 4. Real-time application examples. Nijamaina life flow idi ekkada vaadtam. Like, where do we actually use this? As a developer, you aren't just going to be printing sequential numbers all day. You'll be building software that interacts with actual people. While loops are incredibly useful for input validation. Think about an ATM menu or maybe a login screen on your phone. If you enter the wrong password, the screen doesn't just completely close the app, right? It asks you again. It essentially says, while the password is incorrect, keep asking the user to try again. It is also absolutely perfect for menu-driven programs where you just don't know how many transactions a user might want to make. You use a while loop simply because the number of iterations is completely unknown in advance. Section 5. Advantages and disadvantages, the pros and the pitfalls. So the pros of the while loop are pretty clear. It's beautifully simple, easy to implement, and as we just saw, it handles unknown iterations perfectly. But there is a major catch. The strict requirement of this loop is that you, the programmer, absolutely most carefully update the loop variable manually inside the loop. If you forget to add that I++ to increment your number, well, you introduce a massive risk to your software. Section 6. The infinite loop warning. Caution ahead. As a beginner programmer, this is hands down the most common and frustrating trap you'll fall into.
An infinite loop occurs if the condition never ever becomes false. Think about it. If you start at 1 and your condition is while I is less than 5, but you totally forget to tell the program to increase I just stays at 1 forever. It will always be less than 5. Their loop is going to run millions of times a second, forever, freezing your software and ultimately crashing your whole program. You have to always ensure your condition has a clear way to eventually become false.
And this brilliantly illustrates the binary nature of the while loop's logic. If the condition is true initially, it executes repeatedly as this continuous engine. But if the condition is false right from the start, the loop is completely bypassed. It won't execute even a single time.
So the crucial takeaway here is summarized perfectly in this quote. A while loop checks the condition first, so if the condition is false initially, the loop body will not execute even once. Just always remember that it is an entry-controlled loop. Mastering this single concept gives you so much power over how your code flows and reacts to dynamic real-world situations. Keep practicing your C code, but consider this before you go. We just talked a lot about how dangerous infinite loops are, but what if you actually wanted an infinite loop on purpose? How do you think video games or operating systems keep running continuously without crashing? Think about that for next time and keep building amazing things.